Excellent. Welcome to the TADSummit Innovators. We have Ameed back with us because he's been doing some really cool stuff on a whole host of projects and hopefully interesting products around AI. So Ameed, please let us know what you've been getting up to.
Hey guys, thanks for having me. Good to see you. Yeah, so let me just share a little bit of backstory here, and I'll be diving into some of these things that we're playing around with, and we're kind of like researching and playing around with things publicly. That's why you may see a lot of information being shared online in real time as we're doing stuff. So we decided to make this fun and engaging. So instead of just closing the lab and doing stuff internally, we decided to just be sharing as we go, as we learn, share with the community of people and other companies on what we're doing and what we think is cool. So, you know, our main business is building software for telecom wholesale digital transformation, unifying voice, SMS, HLR numbers, all of that under one digital platform where carriers can use to unify and digitize their operation and enable other CSPs to basically utilize their service using, you know, an intuitive portal or intuitive API that they can interact with things. And actually, our platform programmable interface for wholesale is unlocking some of these use cases with AI that we're going to be looking at today. During the research on, you know, what value can AI unlock for us, and first of all, you know, we wanted to verify, is this just a bubble? Is this real? Is this what's going on there? And what we found out that there was tremendous value coming out of, you know, AI in general. So integrating it made a lot of sense, but then you get to the point where, like, okay, do you build it? Do you use a commercial API provider like OpenAI to do some of the stuff? To find out the right answer, you need to play around with things and get your hands dirty. And that's what we're doing. And that's what we have been doing. And that's how we learn what's the right strategy there. So some of the stuff that we take from learning, we embed into the product to make some functionalities, add some AI-driven functionalities. Some things we would just open source and leave out there for if somebody wants to play around with. So that's kind of like the strategy we've been having. We do believe, even since 2022, early when ChatGPT came out, initially, we had a blog post saying that the key milestones for 2022, 23, 24, it's going to be all AI related, because we did see the tremendous value that it can unlock for telecom in general. So that's what we have been doing. Now let's start out with OpenTextShield. OpenTextShield, you know, you see a lot of these scams going on, smishing attacks and things like that. And it's like no one is, like, there's a lot of talk about it, but we don't feel like there's anything going on to solve it. And as we're researching, we figured out that actually, you know, AI is really, really powerful, especially when GPT-4, when OpenAI reached GPT-4, the reasoning and the actual text classification analysis was extremely good. But we thought initially of, okay, let's just embed or integrate OpenAI text classification to solve this problem with our SMS stack, right? So in real time, when an SMS comes, before it reaches the handset of the user, we should do the analysis and block these messages that we think they're spam. So no one gets even, you know, you don't want to sit down and educate 7 billion people on what to click on and what to not click on. That's not going to work. We need to block it on our side. So we thought that if we have this functionality in our platform, that this would help us upsell more of our solution to operators who could benefit from that, because that's like the first, or that's maybe, you know, on the edge of their network, that's where we sit, and that could potentially block all these phishing or smishing attacks in real time. But what we found out was, so OpenAI text classification works really, it's pretty accurate, but the problem with it was that it takes 30 seconds, around 30 seconds to give you a response. And that in real-time SMS, that's not acceptable. as you may know. So that's when we got into, all right, how can we don't want the whole GPT model. We don't want the whole knowledge of ChatGPT. We only care about text classification, right? In this scenario. So let us try to take down that response. So we want to have an AI model that we train it on what's phishing, what's spam, what's ham, what's okay, what's not okay. And once you train that model, when you give it a new text that it hasn't seen before, based on its previous training, it could determine if this is a spam or not, or a smishing attack or not. And we were able to locate two machine learning models that help us as a starting point to train our own model. So now we're outside of the whole OpenAI ecosystem, and we are training our own models from scratch. And then we found out two models that could be good for speed, which are BERT by Google and FastText by Facebook. These are on our GitHub page. You'll find the documentation for each one. And so to just make it simple, FastText is very fast, but it's less accurate than BERT. BERT requires it's a little bit bigger, requires more computational power, more resources, but it does a better accurate job at determining, text, right? So we trained these two models. We said, all right, so FastText was around like a couple of milliseconds to give you a response. BERT was around 30 milliseconds, 40 milliseconds in that range. And so we started out with those. And then once we trained it, we were testing and we're getting the response we want at around less than 60 milliseconds in general, or with BERT. And that's pretty good because you can now integrate that in real time with your with your SMSC or with your routing, right? Stack. And then when a message, let's say, hits T-Mobile's network, they can do prediction in real time before it actually is getting sent to the handset.
And what's the false positive rate you're seeing? So where it's being flagged, but it's not.
So the accuracy of it is like we're seeing somewhere around the 90%, right? And above 90% of accuracy, and it's much better than any, of course, human being could ever do. And the thing is, okay, even if it's not 100%, even it's between like 90 and 100. Those 10%, because you do get and I'll show you here. So let's say, so let's take this text message, right? Okay, and if we do a submission here, you can see that, it detects it as a phishing attack, right? So this is your PayPal account, blah, 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 and there's a link to click. And this is not a message that it has seen before in the training set. So it's a new message, but it learned from the past that this is likely a phishing, right? Message. And here you will see things like, processing speed and probability, which is like the confidence rate. So based even on the confidence rate, when you're getting the confidence rate, those 10% say that are not like, it's not too confident about that it's accurate. You can like do something else, like send the message, but like rewrite the content, remove the link, or do something else to make it clear for the user, or just block it. It's up to you, right? So the idea here is, like most of the cases I've seen on social media, on Twitter and on LinkedIn, as soon as I dropped it into our model here, just like I'm copying and pasting the text here, it tells you it's phishing. So like literally every case in the last like 6 months, I've taken the text out of that and I put it in the models we've trained, and it caught 100% of them.
Gotcha.
But when you're doing like action,
absolutely,
right? So when you're doing like actual, a large data set of like testing, you will find some around 10% that it could be like improved. But you can, and that's why we open source it, because you can also retrain it, improve it, and go from there, right? So
do you have any deployments of this? So is it out in the field today?
So right now it's I'll show you one initial deployment of this, and I'll tell you what we're gonna do with it next.
Gotcha.
So here in this interface, you can see like you can test this text using the FastText model and one
BERT
powered
one,
by
yep.
BERT, right? So if you do FastText here, you'll notice the processing time and the accuracy is much less, less time. It's faster, but the accuracy is less. So here, when we switch to BERT, you can see it catches it as spam, as phishing, sorry, and at the time, the processing time gets more. And this is running on a very basic hardware, nothing crazy, right? So it can be improved with that. And here you get also, if you want to try it out with doing a real-time API like call to it, you can just copy the code here and either use the BERT model or the FastText model and try it out. Even before you train and deploy it yourself, you can use our free server out there to test it out. And also there's a feedback loop to improve the model. If it believes like this is the bad result, you can improve it there. So one initial deployment we did was, let me show you here. We created a pro version of this powered by OTS, which actually, it became a GPT that combines the OTS and GPT-4 for analysis, right?
Gotcha.
So if you take this text right now and you ask it, like, can you check this message for scam? And what it does, it checks, as you can see here, it's talking to OTS or OpenTextShield on via API. It's getting the results from that, and then it's doing its local analysis using GPT-4 knowledge, and this gives you like a comparison between the two results. So here you can see that the analysis coming from OTS is phishing with this probability, right?
Yep.
And you can see now, just a sec. Yeah, so both models have came up with a conclusion that this is a scam message. Do not click it, right? So so yeah, in this case, this is like a GPT for the public. You can, if you get an email, it works for email, it works for anything. Just drop it in there, drop your message, and it will check our OTS model, and it will check GPT-4 and give you a conclusion of what it thinks. So that's a demonstration of you don't have to only use one model to make a decision. You can actually combine your own model with a commercial one and mix and match as you see fit.
Exactly.
So where is this? So the next thing here on OTS is basically, let me just go back to the paper here. So yeah, on GitHub, if you want to train it, yeah, so this is what it looks like. You have the client making so we have an API interface, just a fast API running in front of it. And then you can just ask it to check using the BERT model or the FastText model, the pre-trained models. And if you want to train your own model, if you want to take what we've already pre-trained and then improve on it, you can just go to these folders. So BERT, you will find two folders, training and tests. Tests include some scripts for testing the model. Training contains all the files related to training the model, right? And training is pretty simple. Yeah, we try to make it very easy for anyone to understand. So in the training here, you basically passing in the file that you want to train it up with. So the file is looks like this. Let me, so the file just includes a data set of some messages that with labels, so the text and the label. So this is labeled as spam, this is phishing, etc. So that's the data set that we're feeding it. And then you have the train OTS here, a script which you're running using Python. It includes the see here, the CSV file, which you're just passing it the file, and then you're executing. And this support, you can train it on Apple Silicon now, and also on regular CPU as you want. So here is a folder for training on Apple Silicon, which you can do it like much faster than on that. And the other one is same structure, test and training for FastText. So we're recently not really spending much time on FastText. We think BERT is already much more accurate, and that the speed is acceptable. So there's no point of spending too much time on that, but it's an option there It just
Exactly.
gives you an understanding.
Now,
So
this is
yeah,
all
so
English language. So have you been looking at other languages as well? Or do you like sort of,
it works with other languages as well. So
okay.
if your data set has Arabic or
Yep.
Russian or whatever, if your data set has that, it will catch it.
Gotcha.
It will,
Understood.
yeah, it will work out of the box. You don't need to, yeah, it's pretty good with that. Yeah, so what's next for us on this is taking OpenTextShield, right, and making it a part of our solution.
Mhm.
So doing more training on it, or producing like a final commercial version of the pre-trained model, and then introducing it as part of our SMPP stack. So
Yeah.
it becomes an option
Gotcha.
for any, to enable AI checking or not. And
Yeah.
it runs locally, of course, on, it will run locally. You don't need OpenAI for this or anything like that.
Exactly.
So TextShield.ai here, or the ChatGPT version, just an idea, just an app idea there that you can try it, today. You can try it today using that interface. But that's
Exactly.
not like what I really care about. Yeah.
Yeah, and it's also
Yeah.
partly building up confidence in how does this
Mhm.
compare to a commercial, so the OpenAI ChatGPT version, and realize, oh, it's the same. So they can build confidence in keeping their data all within their
Mhm.
own network. It's not going outside of the country. Because
Right.
again, that's
And
part of the challenge you
yeah,
have with a lot of
that's very
carriers.
important. Exactly. Yeah, that's very important. You cannot like be sending out all your SMS data for a country to OpenAI and waiting.
Yeah.
And plus, I mean, forget that. Put that aside. It's not practical because it's 30 seconds to get a response.
Yeah.
You cannot use that for real-time
No.
SMS traffic
No.
routing. It's impossible, right? So,
Exactly.
yeah. So you need your own model that's sitting locally with the SMSC. So you will have this.
Gotcha. Now,
33 millisecond.
implementation, because there's a big user experience issue around this as well. Because if you do get a flag, do you block it or do you still notify the customer, but do it in such a way as we have a suspect message, go to this link, or, so do you like have implementation options around this to manage the user experience around a flagged SMS?
Right. That's exactly what we're going to do with once we integrate it with our SMPP stack,
Gotcha.
is making that programmable. So basically in our UI, you will have a configuration option saying, okay, when it's phishing, what do you want to do? When the probability rate is, the confidence rate is low, what do you want to do? So making these options as part of our routing, configuration.
Gotcha.
Then so it becomes very easy for each operator to decide what some of them may just block it all. Some of them may let it go and rewrite some of the links, for example, or something. We'll leave that to the operator that's using that platform to decide on. But we need to give them the tool to make it configurable. For sure.
Understood.
So you're looking to sell this to operators, firewall companies, gateway companies, or what's your predominant? Where you going first with this? The operators?
Yeah, so again, we're trying to provide our platform as a service to operators to digitize their wholesale business from A to Z. And this AI or security or firewall powered by a tool like this is going to be a part of it. It's not
a game changer. It's a game changer.
Yeah.
It's an absolute game changer. And let me ask you one more question, Alan, because I'm getting a little geeky hanging out with you guys so long. So wouldn't an identity product, knowing who somebody is, and basically you guys having this type of product be able to train itself based on relationships and connections that people have had or don't have? Wouldn't it be able to tell, like, hey, I know Ameed, me and Ameed talk to each other, me and Alan talk to each other? Is it machine learning to that level yet, or is that something in your mind? You find, am I making sense to you?
So, Ameed, I'll let you answer first.
Yeah, so good question. So right now, what we're trying to do is something very simple, is we don't care what the relationship, we're not trying to train on that. That's, I think, to be honest, we haven't thought of that because it's way more complicated for us, to know the relationship between people. But the text itself that's being routed through the system, that is something that we can know for sure, that whether this is spam, phishing, or regular text that's being sent between people. So we're focusing on that problem. It's just giving it a large, a good data set, high quality data set, recent data set from recent traffic that we are telling it, this is good text, this is bad text, this is phishing, this is spam, etc. And we're focusing on that problem. So regardless of what the relationship, because you could have a relationship with someone, but that someone is trying to do a smishing attack on you, that still will be caught. It doesn't matter what your relationship is. Whether we're focusing on the text itself, is it harmful or not harmful? And that's a very simple problem for these AI models to learn and to produce good results. And that's what's really been mind-boggling to me, is why this hasn't been solved in a long time. I mean, the last thing that we really care about was, or we wanted to work on, was this, but this kind of came along the way as we're doing things. Yeah,
exactly. Because the model they're using is a text classifier, so it's simple. It's because relationships adds another layer of complexity. I mean, it's interesting, absolutely, but I think
I'm just taking it from the identity conversations we're having with that. No, you should talk to him one day. You guys would talk for like hours together. Forget it. I'll bring a blanket. It would be great though. Just tying in identities. I guess it's just machine learning. It's just the next evolution of what you're doing. But yeah, it's amazing how more people aren't doing this. I think it's because you're a good guy and you're looking to help people and you're looking to do the right thing. Nobody wants to solve anything. You're solving a major obviously it's all we dream about. So this is big for us.
And this is actually the reason why we made it open source from the get-go, is saying, look, right now, as it is, you can take this, deploy it, make your SMSC talk to it, and start using it immediately to stop lots of these attacks we're seeing on social media.
Exactly.
So you don't need to pay us anything. If you want to pay us, then that's when you are buying our whole platform, or when you're working with us on our whole platform implementation, where this is a part of it. But right now, if you're a telecom operator, your IT team can take, for example, this and train it with your own data, or improve it, or just take it
through it. I'm a famous artist, Alan Quayle. I'm a painter. I've got millions of followers. As an individual, could I use this for my own?
Absolutely.
So I'm an influencer, right? I'm an influencer. I'm not. Alan is. Alan's an influencer. Could he use it for his millions of followers that are doing all types of crazy things and fakes and all that type of stuff? So that is you're saying that helps with that as well?
It's a text classifier. So with the image, so it's classifying the text. With the image, there are other solutions. So in terms of you can watermark, I mean, it's like for most of like the big companies like BBC, CNN, if they're going to show an image, there's technology that enables them to authenticate that image as being but there's a number of levels.
You said this product working for social media. I'm an influencer. How would I use it?
So if all your texts are coming into a platform, like all your inbox messages are being somehow available through some third-party app that you're using to manage your followers, then you can pass any text that's coming to you through this, and it will label them in real time using the model. So it depends on whether someone is using Instagram native app to manage 1 million followers, or I've seen some platforms, I'm not an expert in this, but I've seen some platforms to manage these multi-social media accounts. And that platform could use this model to help their influencers to quickly, flag those spam or threatening messages or whatever.
Exactly. That's true.
Here you can see, like, I got a message yesterday. I don't know who that number is. I have no idea. And this is a real spam that came to me yesterday on my T-Mobile cell phone, and I took it random. My model never have seen this before, and I paste it here, and it gives me a spam label, and it's 99% probability. So this could have been blocked by this model, right? Like, for example.
Exactly.
And there's countless examples that you can take and I've tried, even if you take here my some of these open source LLMs that I have running on my machine here, and if you take any of these messages and even try it, like try to bypass it, and it has caught all of them as spam when they are spam. So for me, this already working pretty well. And again, you can train it with your own data. You can customize it how you want, and it's free to use. Yeah, so I hope it helps somebody. And on our side, we'll use it again to embed it to our platform, to increase the value of our platform, so we can sell or partner with more companies with to use our platform. That's the main goal for us to be in. Yeah.
So we've come up on time, because I want to keep these to less than 30 minutes. Otherwise, Johnny starts getting jealous about me giving
No, I'm not
preferential.
jealous. I think this one's important. I think
I know, absolutely.
we need to finish. We need to.
But I
It's
know
about,
one more.
This is important.
Okay.
We've been sitting here for
We could
months
do
trying to
this on
scream
a
about
separate-
finding solutions.
Exactly.
This guy's found a solution
Exactly.
to help people. I mean, how
Exactly.
many people do you stop? How many people can you help? I mean, this fishing and stuff and pig butchering is out of control.
Oh, yeah, no, absolutely.
Just-
Now,
and it's gonna
how
get
long
worse.
would it
I
take
mean-
to go through the next one? I mean, because we could
I'll
do it
make
as a
it
separate. Okay,
like no,
quick.
let's do it as one. 10 minutes, I think will be good. All
Okay,
right.
go for it.
So the next one is our Telecoms Exchange GPT. So this is just demonstrating. So we've integrated multiple APIs of our platform APIs with this to demonstrate how you can use natural language understanding to do many things in the wholesale game. So I'll go through them quickly. So let's say you are looking for the lowest price for a prefix, right? So so what is the lowest price for prefix? 9198. So let's say we're checking India. Please sort by LCR and so let's try it. So you see here, so in this prompt, we're using natural language. We have some spelling or grammar errors in it. And that's on purpose. So we want to just show that anyone could say anything, and it would basically the natural language understanding works really, really good with ChatGPT here. And here it's talking to Telecoms Exchange Market View API, and it's giving us a list of all the vendors. So here it just so list all carriers in a table. Yeah, so it has caught that the least lowest price was via Viber on net route type, and now I asked to just give me all the vendors, and this is happening in real time, giving you the route types, the price per minute, all of that is happening in real time with the API. Okay, now if you can see Tata's price, you can see Airtel's price, you can see all these different carriers. So let's say I want to give me 5 test numbers to India, to this destination. Here, I'm not going to give it a name. I'm just going to say to this destination. It already knows what destination we were in that context. And now what it does, we have another API that will give you good testing numbers that have previously succeeded.
Gotcha.
So here we go. That's coming from the API as well. And then you can do even further. You can say, okay, make a call to Bank of America, Dubai branch. Let me take, this might require authentication. So what I'm going to use is one that I've already had authentication working on it. So this one.
Now, in that pricing, is there a volume assumption?
Sorry?
When they were quoting the prices per minute, is there like a volume? So how much volume you would offer for?
No, so right now this is just giving you the public price or the published prices on the platform that's in the database for all these carriers.
Gotcha.
It does not, like, there isn't that much anymore of like, hey, what is the how much volume, what's the price for that volume? That doesn't really Gotcha. So here we're going to say make a call to Bank of America Dubai branch, right? So here a couple of things happening. How does it know Bank of America's Dubai branch? Here I have an integration with our a CRM API. So it could be your Salesforce, it could be anything, right? And it's pulling that, and you can see here in my screen, I have a call coming, but I'm using my phone as a camera, so I'm not going to pick it up. So that's connecting me to, right from ChatGPT, you're making a call, it's connecting me to Bank of America, et cetera, et cetera. And here you can see the call in real time being routed through Tata, right? So this unauthorized is waiting for for someone to pick up, but I'm not picking up, so it's not going to connect, right? So this is another good example of that. Also, you can send an SMS. So here, send an SMS to, I'll use this number that says your verification code is. So again, putting a lot of grammar errors, a lot of incomplete words just to. So here we're making an SMS sleeve ChatGPT going to our platform. SMSC is then routing it to our number. So the message was sent. So let's see if we got that. Yep, here we go. Here it is.
Wow, cool.
Okay, so this is just a demonstration of how you can add AI or ChatGPT integrated with all the channels, all the different services that our platform offers. This is an example, and I think this is where more and more companies are going to be, businesses and individuals are going to be, using this, not using APIs, not using just prompts and natural language to to communicate, to do a lot of things. And you can go further, create an SMS campaign, craft the messages, and send it all through this with just one prompt. There's a lot of cool use cases. Maybe we can cover it in the future. Yeah,
absolutely. Because I think, because this, mind's racing, because this now extends your market, because you sell into telco, but this dumbs it down so any enterprise, any business could potentially be using that with its CRM to vastly change the costs.
Right, and this is what we're trying to demonstrate for our customers' benefit, and this is what's possible.
Gotcha.
Like if you're using our platform, this comes pre-integrated with all these different things. You can go and sell custom GPTs to enterprises and businesses that use all of your channels using prompts, not anything else. Yeah.
Understood. Oh, that's really powerful. Cool.
You should go talk to BERT with this. Yeah, you should go talk to BERT with this. Right?
Oh yeah, absolutely.
Absolutely, no brainer.
Yeah, cool. No, this was excellent. I mean, again, just because of time, I'm going to cut this short, but thanks so much for these two very powerful demonstrations. It certainly got me thinking.
Thank you so much for having me, and good to see you guys. I'll see you next time.
Thanks so much. Bye-bye.
Bye-bye.